So I suppose we have to remember all the forms of distributing first. So let's do a couple of examples, a little refresher here. How do you know that, firstly, that this is a distribution problem? Huh? Well, the variable, it doesn't need to be a variable. Usually there is a variable involved, but it doesn't have to be. I mean, the x out front could be a 2 and it'd still be distribution. So what of this tells you that we're distributing? Something outside the parentheses, okay. And so then, right, we take this and go into both of them. So then what does that give you? Is that okay? All right, so we gotta know that. And then maybe it's this too. Is this a distribution problem? Yeah, it's actually a fancy one. It has its own name. Yeah, it's foiling. So what tells you that it's foiling? How do you know though? Like what makes you say that I need to foil? No, but how do you know? How do you know? I know we'll get to the how part in a second, but how do you know that it's foiling? How do you know you're multiplying these two groups together, firstly? Yeah, so there's nothing in between the parentheses, right? So that means that it's multiplying. But how do you know that it's foiling? Like if you knew that it was foiling, how did you know? Because a lot of people said they knew. If it's foiling, how do you know that it's foiling? We have these addition and subtraction signs, so there's multiple terms inside of two parentheses, like you said, butted up next to each other. So it's just a really big distribution problem. And so then foiling stands for what? It doesn't really matter as long as you know how to do it. But it's first, outer, inner, last. First, x times x is what? Okay. Plus 8x. And now that was the outers. Right, now you take the negative 3 and go both of them. What'd you say it was again? Oops, there's supposed to be an x there. Minus 3x minus 24. Is that done? No, because there's like terms, and it's never done if there's like terms. Okay, so then what's the final?
X squared plus 5x minus 12.
All right, is that okay with everybody? Well, no, that's a whole big deal. Like, no, we're not doing that right now. No, yeah, no, it's a pretty That's no. I mean, it'll take us like a long time to do it. Yeah. Well, hopefully not a long time, but there's a lot of things going on with that.
I thought you asked that because you were going to show us.
No, that's coming up though. All right, we also need to know how to do this. And this is very recent, so hopefully we all remember how to do this. You know you're multiplying because there's a multiplication sign in there. So that's pretty awesome. So what do you get when you do this? Killing me. No, you can multiply anything together you want. Say it again. Okay, so then what do you get? Right, multiply the outside numbers and the inside numbers. What else do you need to check with always? Simplify. Can we simplify 56? Yeah, because you start breaking it down, right? And it's 7 and 8. and then 4 and 2, and then 2 and 2, and we're looking for groups of what? All right, and so then look, there's a group of 2. What happens with it? So then it's 8 times 2 times the square root of 14, thank you. And so then the final answer would be 16 square root of 14. Okay, and then along with what we just did yesterday with the adding, if that's all okay, then this is going to be a pretty simple next step. Okay, so we're going to take the term out front and distribute it to everything inside. So what's radical 7 times 3? 3 radical 7. What's radical 7 times negative radical 7?
Negative radical 49.
Okay, negative radical 49. And can we simplify that at all? So that becomes 7. So then it's really 3 radical 7 minus 7. Can we combine those at all? Why can we not simplify this at all? Because why? They're not like terms because of that radical 7. Okay? All right, so, you're definitely welcome to go through this step right here. But to make it a little more efficient, you should be telling yourself, well, look, I'm taking the square root of some number times itself, so that means I'm squaring it. Squaring is the opposite of square rooting, so you're just left with what's inside. All right, that makes it a little bit quicker. Okay? Is that okay with everyone? Okay, another distribution problem. So what's the first term going to end up being? 3 radical 20 minus 2 radical 4. Okay, now there's a bunch that we can simplify here. Because 20 can be broken down, we're looking for groups of 2, so we take the 20 over here, and we say, well, that's 4 and 5, and then 2 and 2. Of course, the square root of 4 is 2 also. So then what's this first term become? 3 times what? Square root of 5. What about this second term? Right, because square root of 4 is 2, so then 2 times 2 is 4. Is that okay? All right, now just to make it completed, 3 times 2 is 6, so this is 6 radical 5 minus 4. And again, you can't get any more simplified than that. Those are not like terms. Is that okay? So we're going to take the first term and distribute it. What do we get when we do that? 16 minus 12 radical 2. Is that okay with everybody? All right, now we move on to the second term and we distribute it. Okay. Minus what? 9 radical 4. Is that okay? Now the reason I said this is important is because of this situation right here. This is going to help us later on. Okay, and I knew that was going to happen by looking at it because the terms were the same and the signs were opposite. Okay? And if you're really up on the factoring, that means something to you. Okay? All right, but those cancel out. And then we have 16 minus 9 times 2, which is 16 minus 18, which is negative 2. And that's important to understand what that actually means. What does that actually mean? Huh? There's two of those. That's what that actually means, right? Exponent says multiply the base by itself that many times. So you need to have this. Like you said, there's two of them. Unfortunately, a handful of people are going to not do that, and they're not going to be able to get this right. You have to do that because now you have to FOIL. Does that make sense to everybody? Now, don't be the person that just squares the inside, because that's not what happens. All right, so 3 times 3 is what? 3 times radical 5? All right, now we move on to the next one. What's radical 5 times 3? Okay, and then plus 5, right? You're squaring a square root, so you're just left with what's inside. But you can always go square root of 25 and then simplify from there. All right, like terms, what are they? Let's get them together. Say it again. That's supposed to be a 9. Yeah, my pen didn't work. Okay, so 9 plus 5 is 14. Well, 6 radical 5. Yeah. Okay. Again, you can't combine those because they both don't have a radical. Is that okay? Simplifying on this one. And you can always simplify. There's nothing wrong with simplifying if you think you can. Nothing will go badly for you. Okay, that's always a fine first step. So if you want, we could simplify the cube root of 81 now, or we'll have to do it later. I know what's going to happen on this problem, so I'm going to say we should do it later. But if you said, well, I'm going to see if I can get anything out of the 80, the cube root of 81, that's fine. Okay, that's perfectly fine. But I understand what's about to happen, so I'm going to say let's wait. But we do need to distribute this. So what's the first term become? So the cube root of 3x to the third minus, right, because we're multiplying the inside. He actually multiplied the outside numbers. They were just 1 and 1. Okay, then multiply the inside numbers. Okay, so cube root of 81 x to the third. Again, he's multiplying the outside numbers. They're just 1s. So you don't have to worry about them when they're just 1s. But you are actually doing that. And then the inside numbers. So now we got to go about simplifying it. So what size groups are we looking for? 3. Do we have any in the first one? Okay, so what's the first term become? X cube root of 3. Good. Okay, so yeah, you got to break down 81, right? If you don't see it right away, 81 is 3 and 27. 27 is 9 and 3, and then 3 and 3, and we're looking for groups of 3. And so sure enough, we do have that. And we have this also. So then, like he said, minus 3x cube root of 3. Is that okay? So yeah, that's a good question, right? We have, multiple things are going on here for us to be able to combine these. The first thing is that you always need to check our indexes are the same, the radicands are the same, so then you could say, well, yeah, sure, let's try to combine them. And then it so happens that the outside numbers are also like terms. So we can actually get to negative 2x cube root of 3. Okay, so there's a whole bunch of steps going on, and this is what you're going to find a lot with this level of algebra. It's that none of the steps individually are very difficult, but then they get them all combined, and so you got to remember how to do all these little things the whole time. You have to remember how to distribute. You have to remember how to multiply radicals. You You got to remember how to simplify radicals, combine like terms, like a whole bunch of stuff. Again, nothing super hard. Altogether makes it a little bit more difficult. How's that? Is that good enough for us?